Hello everyone. Today we're going to run through the periodic table MCQ, which includes Group 2 and Group 17. All right. Okay. Just let me just run through a few parts, a little bit of some important stuff that you need to remember for the periodic table. All right. So when we learn the periodic table, we have to learn about the characteristics of the PO3 chlorides as well as the oxides. So in aqueous solution, okay, in aqueous solutions, all the chlorides, sodium chloride is actually neutral. It dissolves in water and it gives you pH of 7. Magnesium chloride undergoes slight hydrolysis. It gives you a slight acidic solution. Aluminum chloride, because it has a higher charge density, is Al3 plus. It can polarize the water even more, and then it gives out more H plus, so the pH is 3. All right, silicon chloride and phosphorus chloride, in fact, they undergo complete hydrolysis with water, and it gives out H plus very easily, right? And these are pH 2. Okay, for the oxides, okay, we learned that ionic oxides are actually basic and covalent oxides are actually acidic. So these two, right, these two over here are actually ionic oxides, so they are definitely basic. Right, they're actually basic, as you can see, pH 13 and pH 9. For the phosphorus oxide and sulfur trioxide, they are covalent oxides. So these two are covalent oxides. Can I write down covalent oxides? All right, and this one is ionic oxides. All right, so covalent oxides, when they dissolve in water, they give out H plus, they're acidic. So you can see the pH is over 2. Okay, for aluminum oxide, it's actually amphoteric, but this is in aqueous solution. Because of the high lattice energy, it actually cannot dissolve in water. So this one is insoluble. Silicon dioxide also has a giant molecular structure. It cannot dissolve in water. All right, so these two will be pH 7. Okay, as you can see from the graph, these are the important pH that you need to remember. All right. Okay, so let's run through the next part. Okay, let's look at the first question. ACJC last year's 2019. Okay, you have to go and memorize and study the charts again if you have forgotten. All right, but this is how it's done. For the first chart, the one with the highest point, right, is for silicon. So please remember that this is actually for the melting point of the oxides, right? Because I know that for the oxides, the highest the peak is the one with the highest melting point is actually silicon dioxide. Okay, so this one try to remember, right? Learn by heart, silicon dioxide. Okay, so this is the first one would actually be the melting point. Okay, melting point of the oxide. This is melting point. All right. Okay, for this for aluminum is the highest peak. This one is for electrical conductivity. All right, this is for aluminum because it has the most number of valence electrons. Can lose 3 electrons. Okay, so this will be the best conductor over here. This S-shaped thing, you must remember, this is actually the ionic radius. Okay, the ionic radius. So this is like Na plus, Mg2 plus, Al3 plus, Si4 plus. Then after that, up here is P3 minus, S2 minus, and Cl minus. All right. So if I just run through very quickly in terms of how you actually see these questions. Okay, if I look at the number of protons and electrons, right, for sodium, the ions from sodium all the way to Cl minus. So sodium actually has 27, sodium actually has 11. Sorry, yeah. So 11 protons. This one has and 10 electrons. Magnesium has 12 protons, and because it has lost 2 electrons, right, so it's 10 electrons. Aluminum would have 13, then here will be 10. Silicon would be 14, and there will be 10. All right. For phosphorus, there are actually 15, 16, 17, but since it gains 3 electrons, it's 18, 18, and 18. Can you see that? So for sodium all the way to silicon, you can see that the nuclear charge actually increases, but they have the same number of electrons, right? So which means the nucleus can actually pull the electrons closer and closer to the nucleus, right? So the ionic radius must become smaller. As you can see, that's actually becoming smaller. right? So same goes for phosphorus, but you can see that from here to here, this is 2,8 and this is 2,8,8, which means phosphorus would actually have P3 minus, have actually one extra shell. So that's why it's really high up there, right? And the same concept, as you go across, the nuclear charge increases by the same number of electrons from P3 minus to Cl minus, which means the nucleus will actually pull the electrons more closely to the nucleus, and the radius will actually drop. Okay, so this is how you tell. So the answer should be D. Okay, the answer should be D.